So now that you're proficient in finding slopes, let's talk about how we can take those slopes and put them into action. So if we're going to try to tell if things are parallel or perpendicular and we had a compass, we could just construct those things. But now that we're taking the compass away, but for good reason, because the compass, frankly, was not a great tool anyway, we need to leave ourselves with a way to actually calculate parallel and perpendicular. And it can't be visual, so we can't fall back on bad habits and just say, well, look, those kind of look parallel, so they're parallel, or those kind of look perpendicular because so they're perpendicular. We can't just make a sketch of it. We need a way to actually calculate or determine it mathematically speaking. And so it kind of leaves us with two very critical questions here. Um, so if lines are never to intersect, in other words, if they're going to be parallel, what does that say about the rates of change? And if lines have to intersect at a perfect 90-degree angle, what does that say about the rates of change? Well, we can kind of make a predetermination here. If we're going to talk about lines being parallel, what's that say about the rate of change? Well, it has to say that they're kind of changing at the same time. So in other words, they change the same. Let me get my pen to work here. So I would say the answer to this first critical question is that they have to change the same. Okay. In other words, if one line is changing by a certain angle, the other one has to change in the same way. Versus over here, when we talk about like the perpendicular sets, I would have to say that these have to kind of be perfect opposites. If they're going to cross in such a way that they make a perfect 90, that means they have to be running in perfectly opposite directions. Now that doesn't tell us much about the slopes themselves necessarily. So let's lay out some very specific slope criteria for both parallel, and do remember that symbol means parallel, and perpendicular lines. And so if they're going to have to run the same way, they run at the same angle, I would say the slope criteria for parallel lines is that they have to be the same, and so they have to have the exact same slope value. And since it was kind of brought up in our previous notes, I would have to also throw in here they have to have different y-intercepts. Okay? Otherwise, they'd be the exact same line, not different from one another. Now, perfect opposites is going to be a little bit different, though. If they're going to be perfect opposites, I think two things need to happen. One, they have to be reciprocals of one another. And we'll talk about what that means, but basically that means the slope is going to have to flip, but also they're going to have to change the sign, or be opposites. Okay? And so what that means, as far as like an example goes, if I have a slope like m, recall is slope, like 2/3, if I want the perpendicular slope, I'm going to have to do two things. One, I'm going to have to reciprocate, and so that's going to turn into like 3/2. And the second thing I have to do is change the sign and to make it -3/2. And this kind of makes sense if you think about it. If you look at the lines up here, if we're going to suppose these are perpendicular, one has to be a negative slope, one has to be a positive slope. Otherwise, they won't actually like cross efficiently. And when they talk about the reciprocation, if they're flipping, well, they're running in opposite directions, and so it makes sense that the slope would have to flip as well. And so these are going to be our check criteria. So if we run into slopes that are the exact same things, and we can prove they kind of have different y-intercepts, we can call them parallel. If we run into slopes that are going to be this opposite reciprocal action, where they both flip, oops, can't read that, where they both flip and then negate, then we know that we're going to have perpendicular slopes. In fact, that's not a bad way to think about it. In general, they're both going to flip, and then they're going to negate. In other words, change signs. So flip, negate, that's going to be the thing to think about if we have perpendicular. So let's look at it in a few different contexts and see if we can work out some examples here. So graph is probably going to be the most common, one of the most common ways to kind of look at this. And so we can fall back into our slope triangle calculations. And so if I look at the slope of the upper line, looks like I'm going up 1. At the same time, I go over 2. And so the slope of the upper line, because it's got to be change in y over change in x, in other words, up, down, before, left, right. Change in y is 1, change in x is 2, and so the slope of this line is going to be 1/2. And so now let's calculate the slope of the lower line. We could do something very similar. And so looks like we can go up 2 here. At the same time, we go over 4, just to pick a couple nice grid lines. And so our slope again is going to be change in y over change in x. In other words, up 2, at the same time we go plus 4. And we can reduce 2/4 as a fraction by chopping both the top and bottom by 2, or dividing top and bottom by 2 as 1/2. And so you can see right now, both those slopes are the same exact slopes, and so these are parallel. Okay, so yep, they're parallel. Okay, let's look at this one here, and so we can do, so even though we don't have like numbers on our grid, we can still calculate the kind of same way. We're just going to need to pick a couple nice grid lines. So here's a nice starting one for that one. Here's a nice ending one. So if we draw the slope triangle, just like you guys have practiced, 1, 2, 3, 4, 5, 6. So it goes up 6. 1, 2, 3, 4 plus 4. And so our slope, in other words, our change in y over change in x, is going to be 6 over 4. Now that reduces, if you divide the top and bottom by 2, to 3/2. And so that'll be the slope for this guy. If we drop down to the lower one, here's that one. Let's see. Yeah, let's choose that one. That's a pretty good one. And so drawing our slope triangle, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's going to be plus 9. 1, 2, 3, 4, 5, 6. And that'll be plus 6. And so our slope here will be change in y over change in x. Change in y. That's terrible. So it'll be plus 9 over 6. If we take 9 over 6 and reduce it, divide the top and bottom by 3, we'll end up at 3/2. And so, yep, it looks like these are going to be parallel too. And so it's not always going to be parallel, obviously, but as long as we can prove the slopes are the same, then we can definitely make the claim that they're parallel. Perpendicular is going to work in a similar fashion. We're going to have to find a couple slopes here. So let's take this slanty line. Let's take that to be our first point. Let's take that to be our second. And so it looks like we're gonna drop down 1, 2, 3, 4, and then head over 1. And so our change in y over change in x for the top one will be negative 4 over 1. Let's compare that to the bottom. So here's a good one, and here's a good one. So we'll go plus 1 at the same time we go plus 4. And so our slope calculation, change in y over change in x, is going to be plus 1 over plus 4, or simply 1/4, because obviously a positive divided by positive. And so if you look at these slopes, okay, if you notice that they both flip, so 1 over 4 becomes 4 over 1, and a positive 1 over 4 becomes a negative 4 over 1, we can say, yep, these are going to be perpendicular, because they have those opposite reciprocal slopes. And so that's the slope criteria. Perfect opposites means two things. One, the sign has to change. That's the negation part. And 2, it has to flip. And so that's flipped and negated. Let's check out this set. So let's take this line first. So here's a good one right here. Let's see. That's not bad right there. Let's take that one. And so to find the slope of this, we'll say we're going to go up 1, 2, 3, 4, 5, 6, 7. And so that's plus 7. At the same time, we're going 1, 2, 3, 4, 5, plus 5. So for this line, our change in y over change in x will be up 7 and then over 5. Let's check out this second one. Let's go gray, actually. So let's see. Find a couple good points. There's a good point. Actually, that's a good point right there. And so, let's see, go 1, 2, 3. That's a -3 drop. And then over 1, 2, 3, 4. So up plus 4. And so for the second line, our change in y over change in x will be -3 over 4. And so if you look at these two values, they're not flipped. I mean, so they're different numbers, even though they have like the plus minus thing. Like this guy is negative and this guy here is positive. They're not the same values, so it's not reciprocated, just negated. And so the answer here is nope, not perpendicular. And so this becomes a check for us. It's not an absolute, but it's a check. So as long as the slopes are the same, we can say they're parallel. If the slopes are different, obviously we can't say they're parallel. And if the slopes are perfectly flipped and negated, so flipped over and the sign changes from positive to negative or negative to positive, then we can say they're perpendicular. If not, well, they can't. And so if we take the graph away, this doesn't change. We just have to find the slopes differently. So like for L1, change in y over change in x. Well, the change in y, recall these are xy points. It goes from -1 to 9. That's a jump of +10. So change in y is +10. At the same time, we go from go to 4 to 6. That's a jump of +2. So that's just going to be +2. 10 over 2 in this particular case will just be 5. So our line 1 slope is 5. Let's check out line 2. So L2, change in y over change in x. And so these points just represent a line. So 2 points make a line, so these are just kind of like the endpoints of a segment, which is not a bad way to look at it. Either way, we're going from a 6 to 5, so that's a jump of -1 for our y's. And then we're going from 2 to 3, -2 to 3, excuse me, that's a jump of +5. And so overall, -1 over 5 just becomes -1/5. And so even though this isn't a fraction, we know we can turn that into a fraction by sticking it over 1. And so we can clearly see that it's been flipped over. 5 over 1 becomes 1 over 5. And the positive 5 over 1 becomes a -1 over 5. And so we can say, yep, claim these are perpendicular. Okay, so we can check these the same kind of way. We just need to look at the line 1 and line 2. And so L1, change in y over change in x. Let's check the slope. -4 to -6. That's a drop of 2. At the same time, going from -2 to 1, that's a +3 increase. And so the slope is going to be +3. And so overall, we're looking at a -2 over 3 for our slope, because a -2 over a +3, negative and a positive always results in a negative. If we're dropping now down to line 2, or L2, if we look at the change in y over change in x for this line, we go from 11 to 13, that's a +2 increase. And then at the same time, we're going from 10 to 7, that's a -3 increase, so it's going to be over -3. But once we simplify it, negative and a positive make a negative. 2 over 3 doesn't reduce. And so we can see here that we actually have the same slope. And so these are going to be parallel. Okay, so just like the criteria says, same slopes, parallel lines. Okay, just like here, we can claim they're perpendicular because of opposite reciprocal slopes. Okay, opposite means change of sign, reciprocate means to flip. And so let's look at our last set here for this type. So line 1, change in y over change in x. This goes from -4 to -1. That's a drop of, an increase of +3. Simultaneously, we're going from 0 to 5, so that's a +5 increase. But reducing it, a positive and negative. Hold on. That should be a -3. Yeah, because no, it's +3. Sorry about that. -4 to -1 should be a +3 increase. 0 to 5 is +5 increase. So in the end, we just have a 3/5 slope. Let's check number 2. So change in y over change in x, very predictable. So change in y goes from 1 to -4. Well, 1 to -4 should be a drop of 5. 9 to 6 is a drop of 3. But we have 2 negatives here, and -5 over -3 will result in a positive, and then we have 5/3. And so here we have actually neither. So this is a weird case, but it's going to happen. Something you have to look out for. It's not parallel because the slopes are not the same. They reciprocated. But it's not perpendicular because they're both positive. And so remember, 2 things have to happen. 1, they have to flip, which did happen. But 2, one has to be positive, one has to be negative, which didn't happen. And so it's neither positive nor negative, and that's a possibility, and you have to look out for it. Last sets, and this should actually go the fastest, these are just pulling slopes from the y equals mx plus b form. And so recall, the slope is always going to be the number in front of the x, and so the slope here is going to be -3. The slope on this one is going to be -3, and since the slopes are exactly the same, we can say they're parallel. We can also observe that the y-intercepts are different, which confirms they're not the same line, but these are definitely parallel. Let's drop down the set here. So this is y equals mx plus b4 on both of them. Number in front of the x is going to be -5/2. Number in front of the x is going to be 5/2. It looks like the sign changed, but they didn't reciprocate, and so this is going to be neither parallel or perpendicular because it doesn't fit the same slope criteria nor the flip and negate criteria. Next set here, slope is going to be a 6. Slope is going to be -6, but we can put that over 1 because we can turn anything to a fraction by putting it over 1. And by doing that, it's clear that this both flipped. So 1/6 became 6/1. So bottom to top, top to bottom, but also one's positive, one's negative. And so these are perpendicular. Okay, slope equals 3/7 here. Slope equals 7/3. And so here's another classic kind of trick. They reciprocated, but they're both positive. And so these are neither. Okay. So that was a kind of long notes. I'm sorry about that, but this is probably one of the more complicated sections. So just a quick recap. You can't tell things are parallel and perpendicular just by looking, but you can acknowledge that if you find the slopes and you evaluate the right criteria, you can tell the two lines, are parallel or perpendicular. If they're parallel, they have to have the exact same slope value and different y-intercepts to make them different lines, of course. But if they're perpendicular, you have to do two things. You have to reciprocate, which means to flip. Then you have to change the sign, take the opposite of, which means to negate. And so a quick example is something like 2/3 flipping to 3/2, but positive also becoming negatives. And so you have to use your skills to find slopes in order to determine if they're parallel or perpendicular. But here's a ton of examples to help you do that. So let's take another break here. Let's pause, do some work on this before moving on to congruency. Thank you.